I do want to let you know too that some of these reaction profiles, they might have like a little tiny funny little step in the middle. So they go up, they've got the activation energy, but then they might bottom out for a second and then keep going. And it's kind of like they have a kind of like a little point down there, right there. That's where the intermediate that's formed, and you'll learn more about intermediates, but that's where this one is stable. So they might kind of have like kind of that hump to them. And that can happen in both cases. The other thing that you want to know is that you can also have a catalyst. So what a catalyst might do for a reaction that looks like this is that instead of having that line the way it is, I'm going to take out that intermediate for a second. What it does is it actually makes it so that it doesn't have to be so high. So maybe it's just like that. And it lowers the activation energy is what a catalyst does. Catalysts tend to be expensive, and they are used in the reaction and then reformed. So I think catalysts are really interesting because there's a lot of research in catalysts that help with all kinds of reactions in the body. And there's different theories on how things work, but in the body, enzymes act as catalysts. And so what might happen is that an enzyme might be designed so that its molecules have kind of like maybe like an open well shape here. And then maybe it has like a long skinny shape here. So that if you have a reactant that has kind of this circle, and then maybe you have a reactant that kind of looks like this, and they have to connect in a certain exact way. Like they have to hit such that just this part hits at a certain part of the circle. That could take a lot of energy to make that happen perfectly, and it could take a while. So what an enzyme does is it's kind of built and it's designed to kind of lock something into place, boom, boom, so they're close enough. So now it holds them long enough so that they are attracted to each other. And once they get attracted to each other and they do the reaction, they don't need to stay connected to the enzyme and they go away. So that's one way a catalyst can work. A catalyst can just do something that helps the molecules like angle themselves correctly. They can do other things too. Like sometimes they can just give, it's kind of like giving someone directions to help them find their way. So there's different ways that catalysts can work. But what a catalyst basically does is it lets us do a reaction that may not be even very energetically favorable by just adding something else in that gets cleaned up and reused over and over and over.